work was to get all these things approved to fly actually with your fixed wing through a city centre?
Well, the process of achieving that was a few months, and initially it was only as visual line of sight. The next step is for you to continually record all your flights, the drone logs, as it were, and to be able to showcase that you are actually a safe pilot that's following the rules. Civil Aviation Authority check regularly with the cities you fly in, for example, air traffic control, and eventually your name kind of gets out there. I'm continually trying to push the Civil Aviation Authority because obviously having a thermal map or thermal camera is all great for, we did some work in Grangemouth where we did the 25 square kilometers and made a 3D thermal map showing the demand on heat. But that was during the day. You know that you want to be flying this during the night. And those legislation is in place, but it's about making the safety case and showing your track record to try and do that. The other advantage of autonomous drones is the fact that with the SenseFly EB, I'm actually able to control up to 8 drones at the same time. Now, at the moment, by law, you can only be one pilot, one drone. But again, these things are starting to change, especially with the recognition that there is a major difference between autonomous fixed-wing drones that are less than a kilo and the remotely piloted quadcopters as well. So it's all about making those steps, and that's why extended visual line of sight was able to be attained by us, because even at 500 meters, I'm not a remotely piloted user, but I would be terrified to have any drone 500 meters away from me and 400 feet up in the sky and still be flying it. Yes?
What wind speed can you fly in?
Well, that's where the money goes, really. Performance of drones is something that I keep a close eye on. This one can fly in up to 30 miles an hour winds. It's encountered stronger because the weather changes every 2 seconds. The only other drone that I've seen so far available that flies in harsher conditions is the Trimble UX5, which is a couple of, I think it's 20 grand more expensive than the EB, at about £50,000, and that can fly in up to about 35 miles an hour. Yes?
Related to that question, what sort of accuracy of track do you have?
Well, your GPS track on the drone is only going to be 3 to 5 meters, but that's why we georeference the outputs to things like the Ordnance Survey's master map or the client's data themselves. There's an RTK version of this drone now available, which allows you to have georeferencing down to like centimeter, like 1 or 2 centimeters.
All right.
So, yes?
Wait, how much is that version which is accurate to a centimeter?
About 30 grand. But it's important to note as well that a drone is just a drone. It's just the hardware. What is far more valuable is our operations manual that showcase our safety when we operate in cities. Yeah. Yes?
What is the scope for sampling, for instance, things like pollen or gases while you're flying?
Well, I mean, this is where you start to look at different sensors. I think with near infrared, you have an opportunity to map things like pollen, but when it comes to gases, you could make the argument that some of this can be detected by thermal light, and you could juxtapose a thermal survey with potentially a near infrared survey to do something like that. But that's when you're looking at attaching more environmental sensors to these drones, and I think that's something that will come on board. It's a lot more popular in quadcopters because you can kind of build them from the ground, which is why I call it drones, but unmanned aerial systems is the preferred term in Europe, not the Americanized UAVs. And a lot of that's because of the software and recognition that it's not just about the hardware, but the software that actually controls it. Yeah. Yes? Oh, yeah.
The picture you showed of Edinburgh, could you explain what that is and how you recorded it?
The 3D map that I showed you there? So that was done with 2 flights. Actually, that's just a small part of it. So the part that I showed was 2 flights that were visual line of sight. Both flights were around about 40 minutes. And then what that does is capture, it was almost 1,000 images. And what we do is we use a technique called stereophotogrammetry, which is, I find it quite funny because I used to study archaeology for 3 years, and that's a technique we used from World War I, where you're taking Russian spy plane images and a pair of stereo goggles, and now for about 10 grand's worth of software you can have the the processing automated. And it's a very powerful tool. The technique is stereophotogrammetry, but it reconstructs the world in 3D using something called structure from motion, which is possible to be done actually through multi-rotor systems as well, if you have the right software. I guess the main difference though is that with a multi-rotor system you would have been looking at maybe 10 flights to cover the same area as well there. Yeah. Yes.
Where were you actually when you were doing these flights? Did you said were a line of sight, so you were standing on the castle, or?
No, not on the castle, on the Prince's Street Gardens. So there's, I land linearly, so I'm not looking for 50 meters in this way, but actually 50 meters this way. So we had a large stretch of the Prince's Street Gardens, and we cordoned that off for both flights as well. So yeah, that's how we did it. There are some cities that would be technically harder to do than others, which is why we're trying to push for what's called beyond visual line of sight. So if you're able to make that safety case that you're always within the sort of underneath the manned aircraft, then you're able to try and push the CAA for that. But
you only get other kind of camera stuff done. You will never get anything with gases also, because you talk about 10 kilos, and if that hits someone, you know, it's not the head who stands afterwards.
Yeah, you see that, and you understand a lot of why I've gone down the road of a lightweight fixed wing aircraft as opposed to multi-rotor, because for me it's all coming from the position of being sort of modern surveying and mapping as well, as opposed to something that might be more dangerous to do in cities. Yeah, exactly. Yeah. Yes?
I was just interested in the type of team that you're building around you to do some of the things that you've described, and the sort of mix between you know, the creative, techie people, the pilots and people who are actually operating, the sales guys. You know, can you just describe what kind of organisation you're building to do these things?
Yep. Well, the company's a geospatial technology company, so everyone inside the company has a geospatial background. The pilots, the remote sensing analysts, and the GIS web developers. Those are sort of the key areas that we sort of bring that core team together. Because one of the most important aspects of what we do is that several of our clients have new ideas that we need to make bespoke processing techniques for. We've got a project next year in Belize looking at mangroves for sort of a tool for sustainable flooding management. And what we need to do is create a geoprocessing tool that analyzes the image, identifies mangroves, and then outputs all the number of mangroves. Another example, again from the road construction with earthworks, is being able to create a geoprocessing tool that analyzes separating what is the natural terrain with the earthworks that exist there. We bring on web developers because sometimes we need the client to identify which features they're trying to extract and do the volumetric analysis on. So for example, roads, that's great, but for me, again, back to the first law of geography, the roads construction team, in this case Costain, they're the ones that know where the earthworks are. So we give them the tools to draw around the features that then sort of subtract that and create a digital terrain model, and the objects and how much volumetric, sort of how much volume of soil there is in that. So for us, it's really about the pilots is the easiest, most scalable aspect of the company, with remote sensing analysts, the GIS experts to make those plugins of geoprocessing tools, and then the web and mobile GIS experts to help bring that into the cloud and sort of have that front facing as well. It's really important. Because ultimately what we want to do is be the ones that help to capture all this new imagery for them. But there's a lot of data and information coming from the clients, and we don't want to upset those workflows. We want to integrate with those existing workflows so that it becomes part of the atlas.
Okay, perfect. I think we need to move on. That was